So in this video I'm going to discuss the definition of limit and how we can think about it in terms of a game between two players. So the easiest limit to define is a limit of a sequence. So let's say that we have a sequence an of real numbers. So n varies from 1 to infinity, and n is a real number for every n, and so we define the limit of an when n goes to infinity to be number L if for every epsilon greater than 0 there exists such n that for every n greater or equal than this n, the following inequality holds: the an minus L is less than epsilon. So basically what this means is that we can make the difference between an and L as small as we need to, smaller than chosen in advance epsilon, by increasing the index of the sequence. So so this is the formal definition, but an interesting way to think about this is in terms of a game between two players. So two players play a game. So the first player, so player 1, player 1 chooses epsilon greater than 0. Then player 2 chooses n, and then player 1 chooses n greater or equal than capital N. So, and the goal of the player, so basically the first player, player 1, he wants the sequence not to converge. So he wants for this inequality not to hold. And the second player wants the sequence to converge, and he wants this inequality to hold. So first player, so these are the rules. Basically there are only so player 1 wants the inequality, so this to be greater or equal than epsilon, and player 2 wants an minus L to be less than epsilon. So these are their goals. So basically player 1 wants this difference to be as large as possible, and player 2 wants this difference to be as small as possible. So they choose, first player first chooses epsilon, then second player chooses capital N, and then the first player again chooses N. And so if player 1 has a winning strategy, so if player 2 has a winning strategy, player 2 winning strategy, then the sequence has a limit, limit L. Then the limit of an when n goes to infinity is equal to L. And if player 1 has a winning strategy, so if player 1 has a winning strategy, then the sequence does not converge to L. It might converge to some other number, but it doesn't converge to L. So the limit, we can write that the limit an when n goes to infinity is not equal to L. This limit, it might exist or might not exist, so the sequence might converge to some other number, or it might not converge at all, but the limit is not equal to L. Yeah, so I think it's interesting to think about the definition of limit in terms of this game, and the same we can think the same when we define a limit of a function. So if we have a function from real numbers to real numbers, we have a definition of a limit. So we say that limit of f of x when x goes to a certain constant number c, that this limit is equal to number L if for every epsilon greater than 0 there exists delta greater than 0 such that for every x such that x minus c is between 0 and the absolute value between x and c is x minus c is between 0 and delta. This implies that so for every x such that this holds, we have the absolute value of f of x minus L less than epsilon. Yeah, so And again, so this definition basically means that we can make the difference between f of x and L as small as we need to, smaller than a chosen in advance epsilon, by making the argument x close to c. So, and again, in terms of a game, we can think about this. So, two players. So player one, first he chooses epsilon greater than 0, then player 2 chooses delta greater than 0, then it's the turn of player 1 again, so player 1 chooses x such that x minus c is between 0 and delta. And so that's it. The game ends there, and then we evaluate the this expression, the difference between f of x and L. So if it is less than epsilon, then the second player wins. If it's greater or equal than epsilon, then the first player wins. So player one. So let's write this. So these are only 3 turns, and then when this all happens, so player 1 wins if f of x minus epsilon is great, oh, not epsilon, minus L is greater or equal than epsilon, and player 2 wins if f of x minus L is smaller or less than epsilon. And again we say that so if player 2 has a winning strategy, it means that he can guarantee his victory regardless of how player 1 would play, how his opponent would play. And yeah, so if player 2 has a winning strategy, then the limit of f of x is equal to L. And if player 1 has a winning strategy, then the limit of f of x is not equal to L. So yeah, I think it's interesting to think about the epsilon delta definition of limit in terms of a game between two players.